Hey data enthusiast, welcome back to Guide Coachings, the go-to channel for all things data-driven. I welcome you to another exciting episode of our Python programming series. We are diving deep into the world of exception handling and exploring why it's absolutely essential in Python programming. Imagine this, you're writing a complex Python code and suddenly an unexpected error occurred. How do you prevent your program from crashing and ensuring it continues running smoothly? That's where exception handling comes into play. In this tutorial, we will uncover the critical importance of handling exceptions gracefully and preventing unexpected errors from disturbing your code. Get ready to learn how to use try, catch, block, and handle that filthy exceptions effectively. And so let's dive into and unlock the exception handling in Python. In case you have not subscribed, please do subscribe us. By subscribing, you are not just keeping up with the latest insights, you're joining a family passionate about leveraging data for success. Now let's talk about the three important topics which we are going to cover today. The first one is what is exception handling, the second is how to handle exception, and the third is why finally is so important. Don't worry, we are going to demystify all these 3 points in this tutorial, so please do not skip and watch the video till end. Okay, and so let's start with the first question first, that is what is exception handling. So in general, there are three types of errors which can occur during your writing of the program. The first one is your compile time error. So if you're writing let's say for loop or if loop, if condition, and you missed semicolon or missed colon, or you written print spelling wrong. Okay, so in that type of errors could be considered as compile time error. While you are compiling the program, the compiler will give you the errors that okay, these are the errors, these are the issues with your code, so please fix them. So once you fix them, then there comes second type of error, that is your logical error. So in logical error, what happens exactly? You have written a program for, let's say, adding of two numbers. So let's quickly jump onto the practical window and I'll show you what I'm talking about. So see this, I am writing print a plus b, print a plus b. Okay, and now I am giving the value as a is equals to 10 and b is equals to 10. So if I execute it, it is giving me 20. But but imagine a situation where I want it the addition and I am doing by mistake multiplication, so my answer is getting changed from 20 to 100. So this is kind of a logical error. Okay, and if I have done it like this, so this is compile time error. During the compilation itself, the error will be caught and it will say that okay, this particular is not working fine, so please fix it. So once I fix it, it will start working. So the first one is your compile time error, the second one is your logical error, and now we are talking about the third and the most important topic, that is your runtime error. So runtime error, what is runtime error? So there are different types of errors which could happen during the execution of the program. It is not a logical error, it is not a compile time error, it could be an error which is going to hamper the execution of the code or the flow of the execution. So imagine the same situation over here. We have two variables a and b, and now I'm printing the values. Okay, now if I am doing the most basic and the most famous example you will find is division of a number by 0. Okay, so this is my number. Okay, over here I have number, let's say 10. Okay, now if I am doing this and I am getting the result as this, and if I add it over here, that is print end of code. Okay, this is how I have written it and I am executing it, so it is giving me the output. Okay, so this and if there is a runtime error, means something happened during the execution of the program, so that kind of errors are going to be handled during this and we can handle them using try catch block. So this is not nothing but your exception handling. So it is not in your control. Your code is written successfully well, it is executed well, but there are certain scenarios, there are certain cases, use cases, due to which if the execution happens, your code will fail. So that is kind of a runtime error. We are going to put some more light on it, and what is the exception handling and how it is important, why we should do it. So the first thing is to prevent program from producing incorrect results due to unexpected errors. Okay, so it protects our code from producing incorrect results. Then the second one is it helps to keep separate suspicious code from main logic. So you have written a huge line of code and there is a suspicious code that okay, due to the execution of this particular code, my whole program will fail, or my whole software will crash due to that particular code. So I will keep that particular code into exception handling, and that is why exception handling is used. Now the third important point is it helps you to keep your code clean and more readable. It keeps your code very clean and more readable. And the fourth point is it helps you to trace back the main error, what exactly is going wrong, so due to which you can do it without crashing your system or without crashing your application. Okay, so now this is how your try catch block will look like. So whatever suspicious code you have, you will write it inside of your try block, and the exception whichever you want to catch it, you will write the exception over here. How it is going to work, we are going to see it on practical window. But before going to that, I would like you to see the hierarchy of the exception. So this is the hierarchy of the exception. This is the base class of the exception, that is the name of the class, that is exception. Okay, and now super class of this is object class. The same is in Java as well. Okay, so here is your exception class, and these are the derived class of exception. Why I'm showing this, I will tell you at the end. Okay, now here see this is your arithmetic error exception class. Then you have name error, value error, type error, OS error, runtime error, zero division error, and floating point error, exception group, permission error, file not found error. So file not found is also a very important aspect when you are dealing with your files. Okay, so we are going to cover the next topic which we are going to cover is file format, how you can handle files in Python. But before that, I would like to talk about what is zero division error and type error. We are going to see the example of these two exceptions, and then the third exception, that is the main exception, how it is going to handle. Okay, so let's see it. This is how it will do it. The once the try is happened, it will go to except, and then it will execute the except block, else it will execute the finally block. Okay, this is how it is going to work. So see this is my example. Over here I have written A and B. Now these are my two numbers. So basically I can give any number over here. I can give 1, I can give 2, I can give 3. Okay, so if I execute it, my program will execute fine. Okay, absolutely fine. But what if the user, or the the user who's using our program or application, will give B value as 0, and as we know, everything what we cannot divide anything by 0. Okay, so it goes into infinite. Okay, the result is infinite. We can write it, but logically in the programming we cannot do it. So if I do it, I will be getting something as zero division error, and this is an error which is happening. So remember this is not a logical error, nor this is a syntactical error or your compile time error. It is at the time of the execution, compiler has found that okay, if you are dividing something by 0, it is not going to execute. Okay, this block of code is not executed, plus this line of the code, that is after that particular code nothing is going to execute, and it hampers your execution. So I don't want my execution to be hampered. I want all the other line of code. If this is not working, that's fine, keep it away, like don't execute it, but execute the rest of the things which are written into the script or which are written into the code. So I want this to executed, but I don't like, if it is not working, that's fine. So what I will do, I am saying my compiler that try to execute it. So what I will write over here is try. Okay, try this. Okay, I know this is suspicious. If user gives our input as 0, I need to handle it. So what I will write here, except. Okay, I'll write except, and then I will write exception, that is 0. Okay, so I'll write it over here, and then I'll give semicolon, and then I'll write print, and then I'll give please enter non-zero values only. Okay, this is the message I wanted to give it to my user. So if I execute it now, see, now it is working. So if user is entering input as 0, it is working fine, and it is giving an error like please enter non-zero value. So user will come to know, oh, I have given a 0 value, so I will change the value to, let's say, 1 or 2 or 3, and now it is working fine. Okay, now imagine a situation, a user comes and he enters a value like this, and it executed like this. Okay, so what will happen now? Okay, so in this situation, again this type error is there. Okay, so what I will do, I will just simply copy this, and I will write one more exception over here, that except, and then I will give the exception name, and then this is exception name, by the way. Okay, this is not something random. Okay, this is known into the exception library or the hierarchy which I have shown you just before this. Okay, so whatever exceptions you are getting, you are writing that over here, and you are writing please enter only numeric values. Okay, this is how you have written, and you have closed it. And now if you are executing it, see, please enter only, okay, only numeric values. Okay, so this is very cool way, okay, to handle your errors, to handle your breaking of your code. So if I write, if user gives 0 as input, so it is going to call this exception. Okay, and if user is giving as w, okay, so it is going to handle it like this. Now I can also create a third type of exception, that is your main exception, the base exception. Remember exception, so I will write except, okay, and then I will write exception, and then I will write it like this, and then I will go inside it, and I will write something like this is base exception. Okay, if I write like this, what will happen? This is going to be cached by this exception, because see, he is the smaller one, he is the father, he is the child. Okay, so if you put child before the father, child will catch it. Okay, but if you put father before the child, father is going to catch everything. Okay, so he is capable to handle each and every exception. So if whether it is a zero division error or it is type error, if you put anything over here, this base exception is going to handle. See this, now it is handling, now it handled the type error. Now if I change this to 0 and if I execute it, see who's handling it? Father is handling, because father has more power. He knows, like your father knows you very well. Okay, you have all the qualities from him. Okay, so that is the reason exception has all the qualities of zero division error and type error. So if you are putting that at first, it is going to handle all the exceptions. Okay, now if you don't write these two exceptions, that is also fine. Okay, I'll delete them. I'll just keep it over here just for the sake of clearance. Okay, so if I execute it now, it is handling. Now if I want what type of exception it is, I don't know, so I will write as E, and then I'll give it as E. Okay, and then I will execute it. Okay, so I'll just delete this part. I don't want this part to be here. I'll just delete it. Now if I execute it, division by 0, see this is the beauty of it. So if I put my father, that is the exception, it is going to give me the name of the exception, that what is the exception I am getting. If I change it to W and if I execute it, see, unsupported operand. Okay, int and string. This is how, but this is not in red. So see this, if I put like this is in red, but this, remember, point this out, that it is not coming in red. So it is just a simple execution, and it is giving me a warning. Instead of terminating my execution, it is saying, okay, please check it out, you are doing something wrong over here, but I'm not terminating your program. So this end of code is also getting executed. Okay, now imagine a situation where if I have written this after this, okay, and if I execute it, so see this, and see this, it is giving me only error and not the next line. Okay, so if I want this line to be executed, what I will do, I'll just copy it from here and I'll just paste it inside the exception, so that it should be printed. If I execute it now, it is printing. Okay, see this. Now I'll change the value. I'll change it to 9. If I execute it, see, my end of code is not executing. So what should I do now? In this situation, I will print it over here as well. And now if I execute it, it is executing. If I put it like this, it is now giving me the error. Okay, like executing the code. But this is just a one scenario where you have one line of code. If you have a huge line of code, or you have a huge logic depend on that particular thing, you cannot repeat it, because reusability is the concept in coding. In every language there is a concept of reusing. Okay, so this has to be managed somewhere. Okay, this communication has to be done in such a situation, in certain condition, that whether this happened, or whether your exception occur or does not occur, execute this. So in that situation, finally blocks will come. Okay, finally, and then you will put it like this. And now if I execute it, okay, if I execute it, it is going to work properly. Okay, so if I execute it, see this. Now if I put 0 over here and execute it, end of code. Okay, now if I execute it like this, so in terms of errors or in terms of success, my end of code has to have been executed. So that is why we are using finally. Finally is a code, finally is a set of code which is going to be executed even exception occur or does not occur. Okay, now why it is important and why it is used? So most of the time try catch is used for file handling concept. File handling, okay, as I mentioned you, we are going to take it next. File handling concept is a concept where you are dealing with files. So imagine a situation, you are working on a cloud server architecture where you have some files onto your server, and you are providing access, or you are writing those files from your client machine. You have written something and you are pushing it to the server, but what if the file is deleted from the server side? You have written the code, you are putting the bucket, so it's like a bucket you have kept, and a null or I'm sorry, if a tap is there, so if you open the tap, the water will flow out of it, and the bucket, if it is placed, it will be filled. If it is not there, the water will be spilled. Okay, so the same situation is happening where you have already connected all the points, all the dots, and you're pushing your file to the server, but the server does not have that file. So your written code will go, your code will, or the code will go crazy, and it will say that file not found. So that kind of exceptions has to be handled using this. And once you are, dealing with files, there is a connection open and connection close kind of a situation happens, where before writing something you will write as connection open. So if you are working with SQL, or you are working with RDBMS, or you're working with Postgre, or you're working with any kind of backend technology, you will write, you will open a connection with the database, and once that is done, you will close it. Okay, close the connection. This is how you will do it. So this is important. Okay, whenever you are doing it, you need to do it. Okay, I'll delete that. Okay, so connection is opened and close the connection. So this is a ritual which we have to do whenever we are dealing with the data, because it is very sensitive if you keep the connection open. It's like your door of your house. You, whether you are going out or you are coming in, after you comes in, you need to close the door. If you are going out, you need to open the door and then go out and then close the door. That is the ritual, we do it. So the same thing is happening over here. That is why finally is so important for file handling concept as well. Okay, let's quickly revise what all things we have done. So we have learned about try catch, try and accept exceptions, how we can write it. So for accepting a exception, we write accept and exception, or we can write accept and the exception name, and then we will be writing inside it, we will be putting the code or the statement which we wanted to give as a instruction. Okay, and there are three types of errors: compile time error, logical error, and runtime error. Okay, the runtime error could be of zero division index error, array index out of bound, very famous, array index out of bound. Okay, type error or file not found error. These are the types of the errors which can happen or which can lead due to not present of exception handling. Then the most important point which I would like to make over here is, whatever you feel is suspicious or whatever you feel is doubtful code, you keep only that inside this try block. Okay, see this is the suspicious code which I have written. If I have written like this as well, it would have ran. Okay, there's no problem in that. Okay, but what is the problem? The problem is, if I put try before it, like if I put try before it, or if I try to cover each and everything inside the try, what happens is, I'm sorry, just give me a second. So I'll just retry it. This is the error. Okay, so see this. If I try to run it, it is working fine, absolutely fine. Then why I'm not writing it over here and I am precisely writing it over here is the reason that try makes your execution process slower. It pay attention to all the suspicious code, because he feels that everything whatever written inside me is a dynamite and I need to check it before putting my feet. So it checks it very carefully and goes further. So that is the reason you need to keep only suspicious code into try block and not everything into the try block. This could be an interview question for you if you are preparing for the interview. Keep that in mind. The next point is, keep all the exceptions types above exception at it handle all the exceptions. As we have seen it practically, if you put exception as above all the exceptions, it is going to handle it. This is again a second tricky question which is going to be asked into the interview, that what will happen if I put exception at the top and file not found exception, error type error, or zero division by zero error, what exception will be executed first and why. So exception is the base class of all the exceptions, so it will handle all the exceptions if you put it at the top, and if you put it at the end, if no other exception is occurred, the third exception or the last exception will be definitely going to catch that particular exception. Okay, so this is how the hierarchy of the exception file is, where we have the topmost exception, and above it we have the object type, that is object class, and this is your exception. It is derived from object, and now these exception have these many children. Okay, these are the derived classes of the exception. Okay, that's all for today, guys. If you like the video, if you have any questions, any queries, or any doubts regarding the topic which we have covered today, you can write me a comment and we will be discussing it into our next session. That's all for today. Thank you so much, guys. And if you have not subscribed us, please do subscribe. It motivates us and help us to create more videos like this. That's all. Thank you.